supports all languages, so you don't have to deploy them separately. I think this is where it all starts in terms of generative AI. Of course, the next thing is you got to make the AI speak back to you, and that's where we have Sarvam Bulbul, which is our text-to-speech model. Whether you're experiencing it as a voice bot or a voice mode in a phone, this is what you actually touch. And this is what Sarvam Bulbul does. We now have built very natural, expressive Indian voices for a variety of use cases, right? Whether it is storytelling, whether it is a voice of a person in a contact center, whether it is someone acting a bit funny, all of those things are supported. These are low latency models which can support streaming, so you can actually stream the audio back, and they are production grade in terms of stability. This is very important because often you do not recognize that in these large language model-based tools, there is variation, and the variation can be high for audio synthesis. And we have focused a lot on ensuring that there is stability between generations of this audio, stability across multiple turns, stability across long tail of words, etc. So in terms of benchmarks, on the 8 kilohertz frequency, which is what you hear on a telephone, we have compared externally the preference of our model with models from other companies and clearly find that Sarvam Bulbul does much better. In fact, at the cost point it is available, it is a significantly obvious choice for all folks building with voice in India. So I'd like to call on Himanshu on the stage to again show some cool demos.
Hello everyone. Thanks Pratyush for talking about Bulbul, but now I will let Bulbul do the talking.
That was so funny, lol. मैंने joke किया, उसके बाद मेरी हंसी रुक ही नहीं रही. But honestly, today was a bit much, yeah. Like, tell me, what on earth is wrong with Rohit? Every single time, full drama mode, one thing after another, and I kept thinking कि बस कर भाई, अब और नहीं, please just spare me. But then, I don't know, talking to you right now, it's kind of nice, makes things feel a little lighter, you know.
ये कॉन्सेप्ट छोटा है लेकिन बहुत पावरफुल है. ओके, मान लो आप साइकिल चला रहे हो, रोड एकदम स्मूथ है, नो प्रॉब्लम, राइट? साइकिल इजीली मूव कर रही है. अब वही रोड अगर रफ हो जाए ना, सडनली पेडल मारना थोड़ा हेवी लगने लगता है. यही है फ्रिक्शन.
100 வருஷத்துக்கு முன்னால் இதே இடத்தில் நடந்த பெரும் போரையும், போர் நடந்த பிறகு இங்கே வெகுநாள் வரை இரத்த வெள்ளம் பெருகி கிடந்ததையும் பார்த்திருக்கிறீர்கள். மனிதர்கள் எதற்காக இப்படி ஒருவரை ஒருவர் பகைக்க வேண்டும் என்று அதிசயிக்கிறீர்கள்.
So as you see, Bulbul can gossip better than your best friend. It can explain you topics in a way you wish your teacher did. And it can even narrate your native folklore stories, just like your grandparents. So see Bulbul in action.
V2 अच्छा था.
V3 में गेम बदल दिया. Let me show you how.
जब आखिरी विकेट गिरा, कुछ सेकंड के लिए सन्नाटा हुआ, and then people just exploded with joy.
ઓબ્જેક્ટ પર ફોર્સ લાગતા તેનું મોશન બદલાય છે. આ ન્યૂટને સમજાવ્યું હતું.
இன்று மாலை 6 மணிக்கு நம்ம ஈவென்ட் ஆரம்பமாகும். தயவு செய்து உங்கள் சீட்ஸ் எடுத்து தயாராக இருங்கள்.
আজকের এপিসোডে আমরা দেখব কিভাবে আর্টিফিশিয়াল ইন্টেলিজেন্স আমাদের জীবন বদলাচ্ছে.
So be it voice bots, content creation, edtech, just bring your use case and make Bulbul your voice.
Thank you, Himanshu. Again, would like to recognize how important it is that right? And the ideas should flow through no matter what language you are speaking. All right, so that is dubbing, state-of-the-art models in that and already deployed at scale. I would now like to move on to vision. It's yes. I mean, in the human brain, for example, the amount of gray material for vision is so high. It's one of the most important perceptual tasks. And it's an area which started from scratch in the last 8 months and have now built state-of-the-art models in this area with a small team which is pulling quite a bit of weight, right? Our focus was quite a bit on general vision recognition, but with a focus on document intelligence. We are very deeply interested to digitize documents, whether it is ancient documents in variety of scripts or modern documents with complex tables, handwritings, notings, etc. So quite a bit of understanding was focused on, given a document, extracting the layout appropriately. How do you read the page? Visual grounding was also an important thing. You need to take large language models and ground them on understanding vision. We, of course, also had to tailor it for various components. What I mean by that is we took from scratch a 3 billion parameter model. It's called a hybrid model because it combines state space with attention-based layers, making it very efficient. We trained this model for, I think, about 16 trillion tokens of Indian language, of English, code, etc. And then we took this model and grounded it on vision capabilities with a continued pre-training on 400 million images. That's the visual grounding, and by adding these new components for vision. And then this became the baseline with which we then fine-tuned models for different tasks. And here is a benchmark that is making quite some rounds. On an international benchmark, Almost CR, which is by Alan AI, which is a non-profit working in the space of AI. They released their own models in the open source. On English, we were able to perform the best, improving on variety of models, including being able to detect tables, handwriting, math, multi-column, all kinds of complexities that documents have naturally. And this is a combination of high quality, continued pre-training, the supervised fine-tuning, and as you can imagine, reinforcement learning. The ability to take a task like vision and be able to improve it with reinforcement learning to solve these long tail of problems was one thing we focused on. And I think we are just getting started in vision. As I said, 8 months back, we did zero vision at Sarvam. Today, we have a state-of-the-art model. And we are just getting started, and we feel very excited that we will build very strong models on all aspects of vision, including, for example, detecting what's happening through a CCTV camera. Also on Indian languages, our lead is even higher. We are comparing ourselves against models of much, much larger sizes, and we are able to significantly improve accuracy. I would now like to call upon Krishna to talk more about this.
Thanks, Pratyush. Good afternoon. I would like to say, what is high-fidelity document digitization? It's not just a simple text extraction problem. It is much more involved. For example, there are several types of documents which have much intricate complexities, such as newspapers, government records, textbooks, and so on. All of these have to be identified for their structure and the content they have within them. So how do we do that? Firstly, we do document layout understanding. What that means is, given a document, we are able to parse where is a page number, where is a heading, where is a paragraph, where is a table, and so on. Now, with this information, what we are able to do, next slide, please. Yeah. So with this information, we are able to perform visual grounding and reading order predictions, which mean that given a complex newspaper with easily 100 blocks here, we are able to say what is the headline, what is the title of a article, and then say that is order number 1, 2, and so on, all the way unto 108 reading order. So with this kind of visual grounding and layout understanding, we've been able to put a very tight harness around the Sarvam vision model. So moving to the next example, in addition to all the harness that we have, we also do something called knowledge extraction. Most traditional vision language models and OCR models perform text extraction. What we do at Sarvam is much more advanced, which is knowledge extraction. For example, the chart present up there is not just extracted with the text there, but we are able to caption it in various languages and present them in Markdown and JSON and other complex formats so that downstream applications can easily ingest the data. And finally, with all of this architecture, we've also been able to solve some of the most complex handwritten documents, which on the left you see, this is a letter from Abraham Lincoln from 1800s, and this is from Dr. B.R. Ambedkar from early 1900s, and we've been able to digitize it with like almost 100% accuracy, and this is Sarvam Vision for you. Thank you.
Thanks, Krishna. One use case of vision that I am very deeply passionate about is using vision for recognizing what students have written on paper to digitize their work and then be able to provide them personalized feedback on what they learned and what they did not. Because in the absence of being able to recognize actual human work, we are restricted to forcing students to always go through digital interfaces. So imagine students across the country writing exams on a weekly basis, not to be tested, not to be evaluated, but to be given exact feedback on what they understood and what they need to improve on, right? I think that is a genuine possibility with the work we are doing. In fact, we are collaborating with DPS School, NCRT, the Ministry of Education to make that happen in this academic year. Now, I would like to talk about our large language model. We have been, of course, building models across the vision model, for example, is also a large language model, but it is a 3 billion parameter dense model, again trained from scratch by us over the last 8 months. But it is important to scale up. And there are 2 other models that we trained, and we are talking about releasing them today. One is Sarvam 30 billion. This is a 30 billion parameter model. Of course, all of you know that the larger the model, the more the parameters in it. It is more capable, but of course, it is harder to train, takes longer to train, and longer to run in production as well. But 30 billion in today's time is a very small model. It is actually a mixture of experts model. It has actually just 1 billion activated parameters, meaning we have a 30 billion parameter model, but in generating every output token, it only activates 1 billion parameters. Other competitive models, such as Quen 30 billion, for example, have 3 billion activated parameters, right? So even in the mixture of experts world, we have gone towards systems which can be very, very efficient for inferencing. It supports a context length of 32,000, meaning that you can have long-running conversations with it, long-running agentic interactions with it. It is pre-trained, again from scratch, on 16 trillion tokens of text. This is a lot of tokens. So a token of text, think of it as about 2/3 of a word, right? That's a good estimate for English. So you're talking about trillions of words of text that have been used to train this model, again curated completely within Sarvam. It also is a very, very efficient thinking model. It beats all models out there, office class in efficient thinking, and I'll show you the results of it. Again, this is towards the principle of making these models efficient. These are reasoning models, then they think, but the amount of thinking they do can impact how long it takes to get an answer, how costly it is. We have worked to make it very, very efficient. And finally, the intent of this model is to be a real-time conversational engine for things people build. It's small, it has 1 billion active parameters, it has a large context window, it allows you to work with Indian languages and then have conversational experiences with users. Quickly showing you benchmarks. These are very popular international benchmarks on math, programming, knowledge, and you can see our model being compared across open models from different companies, and you can see that in variety of those things, the Sarvam model, Sarvam 30B, actually does exceedingly well. And if you look at agentic benchmarks, where agentic is, of course, where there is tool calling, there is usage of multiple tools which the model has to choose from on variety of things. For example, browse comp, it is the ability to use the web search to improve the answers that the model gives out. On SweBench, which is about programming, on Tau Square, which is about tool calling, you find that our model is competitive with the best models that have been released in this model scale, while being significantly smaller in terms of the number of activated parameters. If you look at thinking budget, it's one of the most important things here, which is how long do you give the model to think before you can answer? And on the x-axis here, you can see how much of thinking is allowed for a model before it answers questions on math from this benchmark called AIME. And you can see that other models perform very, very poorly if asked to be, in some sense, fast, asked to be compact. And you can see that the Sarvam 30B significantly outperforms both at the 8K and the 16K scales compared to the latest models that have been released from other companies at the same size. I just would like to again bring this into focus to what we are doing. We would like to make AI work at a population scale, and being able to do it efficiently becomes a very, very core thesis. And things like this add a huge step up to how efficient these models are. I can actually deploy a model with much smaller token budget, achieving the goals which would otherwise be much more expensive. Also, on another task here, HMMT, even in this task, you can see that the performance significantly is higher for both the 8,000 and the 16,000 token budgets. Of course, this is English, math, reasoning that I showed you. On Indian languages, we of course do very well, whether it is on fluency, being able to follow a particular language, usefulness, conciseness, we significantly outperform models that have been released in the open source at this model scale. In fact, these benchmarks don't do justice to the fact that the model understands Indian languages natively. It can answer a question in math specified in an Indian language while being so small, right? And to therefore demonstrate those use cases, I would like to show how India at scale can use a model like Sarvam 30B by demonstrating what is possible with a feature phone. And to do that, I would like to invite Aditya.
Thank you, Pratyush. Super excited to be here. Just wanted to, I think, referring to what Pratyush has said, I think we want to serve 1 billion Indians, and small, efficient models are important for that. And what we have been able to do is plug this 30V model into a conversational AI assistant. And you can actually use the conversational AI assistant through a phone call. And that's what I'll be demonstrating.
You can mention what phone is that. I don't suppose people see.
So this is a Nokia phone. विक्रम जी, ये बताइए जो AI Impact Summit हो रहा है दिल्ली में, उसके बारे में थोड़ा बताइए कि ये क्या है एंड क्यों ज़रूरी है?
एक सेकंड रुकिए, मैं चेक करके आपको डिटेल्स बताता हूँ। तो देखिए, ये AI Impact Summit 2026 का सबसे बड़ा इवेंट है, जहाँ जहां भारत के बड़े टेक लीडर्स और स्टार्टअप्स आ रहे हैं, ये इसलिए जरूरी है क्योंकि उनका फोकस भारत के एआई इकोसिस्टम को मजबूत करने और तकनीक के जिम्मेदार इस्तेमाल पर है। क्या आप इसके बारे में और जानना चाहेंगे?
नहीं विक्रम जी, मेरे को ये बताइए आपका नाम विक्रम क्यों रखा गया है?
देखिए, मेरा नाम विक्रम इसलिए रखा गया है क्योंकि मेरे नाम के पीछे एक प्रेरणा थी। मैं विक्रम साराभाई के नाम पर बना हूँ, जो इंडियन फिजिसिस्ट थे और जिन्हें भारत के स्पेस प्रोग्राम का पिता माना जाता है। उन्होंने इसरो की बुनियाद रखने में बहुत बड़ी भूमिका निभाई थी, तो उनके नाम पर मेरा नाम रखना मेरे लिए सम्मान और प्रेरणा की बात है।
अच्छा, आप विक्रम साराभाई के बारे में कुछ और बता सकते हैं क्या?
हाँ, तो विक्रम साराभाई का जन्म 1919 में हुआ था और वो एक बड़े साइंटिस्ट थे। उन्हें भारत के स्पेस प्रोग्राम और टेक्नोलॉजी।
आप ये पंजाबी में बोल सकते हैं?
हाँ जी बिल्कुल, मैं तुम्हारे नाम पंजाबी विच गल कर सकता हूँ। सो विक्रम साराभाई
Yeah, so this is what the 30B model can do. Vernacular, low latency, high performance for a billion Indians. Back to Pratyush.
So just to recap, this was a 30 billion parameter model trained from scratch in about 16 trillion tokens, supporting Indian languages with a very, very efficient custom tokenizer we have built. Very significantly small activated parameters makes the cost of inferencing very low, supports state-of-the-art performance on things like browse comp, which is required to search the web and answer questions like this, able to do agentic tasks very well, and on all other things like math and reasoning is very, very efficient at much smaller token budgets, right? So we think of the 30 billion parameter model as the efficient workhorse that will run at scale to power a billion conversations a day. And we're looking forward to deploy that across all the things that we do at Sarvam. All right, now moving on to the next model that we train, So we trained a 105 billion parameter model. Now, this is also a mixture of experts model. It actually uses 9 billion activated parameters. The ratio of activated parameters is actually larger in this model. But the reason we did that is because it uses efficient mechanisms of what is called MLA to make inferencing more efficient at this size, such that it is roughly about 2 times more expensive than serving compared to the 30 billion parameter model. It has a larger context window of 128,000 tokens, therefore allows you to do more thinking and do more complex tasks. It is on par with most other open models and also with several closed source frontier models of its class. And it is also designed to do complex reasoning tasks very well. I would like to now show you some benchmarks. These are again hard reasoning benchmarks, GPQ at Diamond, AIME 25, Beyond AIME, HMMT, and MMLU Pro is a knowledge task. And compared to even larger models like the GPT OSS 120B, GLM 4.5 Air, again a larger model, we perform very well across the benchmarks in this particular model. And these are, just to give you a sense, pretty high numbers where you can solve complex tasks with a model at this size. In terms of Indian language performance, you can clearly see that we perform much better than models of from other companies. In fact, even with something like Gemini 2.5 Flash, which is a bigger model, more expensive model, we find that the Indian language performance of this model is even better, right? On live code bench, which is a programming task, we find that we are almost close to the best models out there at the model of this size, enabling this to be used also for software engineering, where you can fix smaller bugs, write smaller pieces of code with this particular model. On browse comp, again, something that we have focused a lot on, which is being able to search the web, we find that the model outperforms other models significantly, and hence will be able to effectively use search in grounding its answers. Right? In terms of agentic tasks where there is tool calling involved, we are able to show that the model actually outperforms different models at its scale compared to how they perform. We would like to welcome Honorable Education Minister to the presence. Thank you, sir.